Hello, Chad Tope, here to present my semester project for CIS 352. Here we are actually in my dashboard. I just wanted to start, before I get into things, just pointing out my source material is the National Library of Medicine's periodic table. I believe this was the download link that I used to get the table. There's actually quite a bit built into here. You can sort by any of the data values that they've provided actually in the download table, and it's decent enough. I'll say it's nice to get an overall picture pretty quickly. And then down below you've got some certain plots that they've got. Here's the density one, the atomic mass, and it's nice to see those kinds of trends in the data. Interesting to look at, but what you can't really do is kind of cross-pollinate those things. So I thought it'd be kind of neat to do that, and that's the intent of my semester project. So before I get too into this ending here, I want to go back and actually walk through the tables that I've made, or the worksheets that I've developed off that data. First, pretty simple. I've just got the elements laid out per year discovered, and just to add a little bit of flavor to it, I've assigned the standard states as a colored code here, and I got the legend up on the right. And fairly simple table, but kind of shows you a couple of things. I thought it was actually pretty interesting. The bulk of these really well-known elements, just going back prior to the 1600s, just thousands of years beforehand, essentially. Pretty good start, obviously, but very fascinating, I think, to see where all of these gases were discovered at around similar times, kind of indicating breakthroughs in technology or methods, or something giving way to those discoveries. Just interesting way to look at it, something that you don't really see on the front page there. So this one actually, it's a mosaic, I guess you'd call it, with it's got them elements separated by groups, and then within the groups they're organized by oxidation states. A lot of what I did in this project was actually looking at how the oxidation states relate to the other values, just because I just find it wicked interesting, especially following a chemistry course not so long ago. It's just one of the coolest things in natural science to me, these pre-existing relationships, I guess. So yeah, just an interesting, beautiful artsy looking graphic that plays well with what I'm doing here. So next one we're going to look at is the just visualizing the distribution of mass by oxidation number, and to do that I've actually got the size and the coloration set to mass here. And so it kind of shows a beautiful gradient here as far as where the low mass materials are, and how they are represented in our physical reality across our states of matter. Honestly, this one really benefited from removing the these theoretical type values where perhaps we've predicted or simulated these materials, or had them for a short short amount of time enough to name them, but they can seem to kind of pollute the data here, because again, those are expectations. These are actual measured observations that we've got. So again, cool to see how essentially the low mass elements, are dominating gas, the gas category, as compared to higher mass elements, which again kind of makes sense when you think about density and whatnot. Speaking of density, this one is kind of interesting. It's displaying the kind of the natural relationship between density and melting / boiling points. I named it melting point because that's what I've actually got it plotted to here. It's melting point in Kelvin, and additionally I've added the coloring to match to the boiling point. I actually, when going through and playing with it, I discovered that to me it was really interesting how we've got the boiling points aren't necessarily as correlated with the melting points as one might think, without really thinking about it too much. And then of course, very interesting pattern kind of emerges throughout this, throughout the plotting here, where you've got these kind of like these three distinct branches coming up, and then following that you've got these these outliers out here, being boron and carbon. And carbon's actually a huge outlier with its melting point and boiling point being so high, but yet its atomic number being so low. Again, boron being not, it's one atomic number less. Kind of interesting how 5, 4, 3, they all kind of come out of this really interesting curve there. So yeah, moving on. This I took it a step further, and I'm comparing the melting point to the boiling point and creating a bar for that distance, and then you'll see a little bubble kind of at the top of these, and that actually represents the boiling point. And these are plotted on a synchronized axis that is been normalized. So the actual melting point ought to be plotted. For example, this one's 454. You see it just under the 500, up to the boiling point of 1615, just over the 1500 marker. So as you can see, these are actually, they're not scaled or skewed at all, which makes it really interesting when you again look at these elements that are essentially the outliers that have differences of 6, 3, 14, these really tiny differences. And then this one actually really stands out a lot too. Arsenic has actually got a negative difference in boils before it melts, which is, I don't know if that's a fluke in the data, or I'm gonna have to Google that after this. But moving on, I'm running out of time here. Here where I took a little effort to build a filter to break apart the oxidation numbers, and could have used Excel, but ended up doing it through Tableau. Again, I color coordinated based on standard state, to show the relationship between gases, liquids, and solids being the brown there. There's a clone of that one, but with group coloring applied, just because that's interesting on how those distributed across the oxidation. So it brings us to this main dashboard, which again intent is to kind of blend these various trends throughout the data. Works pretty well. It's a little bit of delay, but there's a lot of data in there. And I think the coolest part is that now you can do those restrictions and then hop back over to these, these other graphics, and they'll have those filters applied based on the way I'd set it up. So it kind of gives you the deep dive. And I did one probably a little crazy on this dashboard. You've got the ability to download a PDF of what you're looking at, or all the workbooks. Here you can actually swap out the one you're looking at, so you can see those groupings with the oxidations, or you can actually look at the oxidation number chart plotting. So yeah, lots to do here. I'll go ahead and get that submitted with a video. Say thanks for watching. Hope to have another course soon. Take care.